Hi guys, this is Mrs. Gassler, and in this video we're going to talk about ions, different kinds of ions and how they form, as well as some patterns in the periodic table. Let's get your Cornell paper, and you'll also like to have a periodic table handy. So here's our Cornell paper. Make sure you put your name, class, period, and date right there. Our topic is ions, and we have two essential questions. Well, the first one is, what is an ion? And the second question is... And our second question is, how do they form? So when we talk about what an ion is, there's kind of a general definition that an ion is a charged particle. It just needs to have a charge to be considered an ion. And then the type of ion and how it gets that way kind of helps us understand what an ion is a little bit better. So we've got two types of ions. So the first type is an anion, and that is a negative ion, and I remember this one because it literally says an ion in it, a negative ion. So we're talking about a negative ion here. In order to be a negative ion, the number of electrons must be greater than protons. So remember, our electrons are the negative ones and our protons are the positive ones, and to be negatively charged we have to have extra negatives. We'll talk about how that happens in a little bit. So our other type of ion is a cation, and this one's not quite so easy to remember, but if you know it's not negative, it's the other one, right? This is a positive ion. I see the plus sign in the word cation, and I remember that's a positive sign, and so cations are positive. Do pay attention to how you pronounce anion and cation. To have a cation, what we need is the opposite of an anion. So our electrons have to be less than our number of protons. So if we talk about how ions form, what we need is a generic atom. So I'm going to draw a nucleus and some energy levels here. And we'll have our example. Maybe it has 4 protons and 5 neutrons. To be neutral, it has to have 1, 2, 3, 4. Neutral has the same number of protons as it has electrons, so that would be a neutral atom. Now, if I change the number of protons, I end up with a new element. I don't want a new element when I have an ion, so this is not how I get an ion. What I need to do instead is change the electrons. So in order to have an ion, what we have to do is we have to change the electrons. So let's talk about what we're going to do to make an anion or a cation. So to form a cation, we want to have more positives. But since we can't just add positives, what we have to do is lose electrons. If we lose electrons, that means that we'll have extra protons, which will give us our positive charge. Now let's apply the same thing. If we want an anion, we would need it to have more negative charge, which means we have to gain electrons. We could take away protons, but that doesn't happen so easily, so we actually gain electrons. So cations lose electrons, anions gain electrons. So let's talk about the charges that they get and some patterns in the periodic table on the backside. Okay, so here we have a little blank periodic table, which you already have somewhere in your notes about valence electrons, so you don't feel like you need to have to write this down right now, but there's a pattern that we follow for the number of valence electrons. So remember, these guys all have 1, these guys all have 2, these guys all have 2, down here is 2, over here is 3, we're counting the tall columns, there's 4 and 5, and 6 and 7 and 8, and the only exception is helium up here with 2. Now remember, this is mostly because of the way the electrons fill the orbitals, and that's going to be something that we're going to think about. So when we think about whether or not it makes a valence electron, there's this thing called the octet rule. The octet rule says that atoms are the most stable with a full valence level. Now, if they're bigger than helium, if they have enough electrons, most of them, especially in the second period and the third and the fourth, who have electrons on the second and third and fourth level, That's where that octet comes from, because they have they kind of want 8 valence electrons. The only exception is the first like 4 or 5 elements. They just don't have enough electrons to get to 8, and so they end up wanting 2. So that's a useful thing to note. But so the gist of forming ions is, let's make a number line here, 0 and 8, and we'll split this up here. So 4 would be in the middle, 2 would be here, 1, 3, you get the idea, right? Okay, so if it's 0, something special happens. The level that is below is automatically full. So if it does lose its valence electrons, then the next level becomes the valence level, and it's already full. So if you think about it, it's really kind of about ease here. We're talking about electrons that don't like each other, so it's going to be really hard for an atom that's, say, here, to gain 6 electrons to have 8. So it's a lot easier for that atom to just lose 2. Likewise, over here, it's a lot easier to just gain 2 than to shed all 6 valence electrons that it has. So we think about this when we think about what kind of ion forms. So I'm going to add in another copy of that little blank periodic table. You should add this onto your copies of the blank periodic tables, or draw it wherever you'd like to, so we can see the patterns. Okay, so when I think about the charge of the ion that forms, I'm going to remember that these have 1, 2, those are pretty much all 2, and then I've got 3, 4, 5, 6, 7, and 8 valence electrons. The guys that have 1 electron, it is so much easier for them to just lose it. When they lose it, it will become positive, and it will have a charge of 1 because it has 1 extra proton. In the second column, these guys they lose an electron, so they gain a positive charge because they will have 2 fewer electrons, so they'll have 2 extra protons, so they become a charge of +2. These guys in here are generally +2. We'll talk about some exceptions later on. Over here in the 3 column, 3 is right about here. 3 is a lot easier to just lose than gain. Lose 3, gain 5 are your choices. Lose 3 is the way to go, so these become positive also. +3, that's a 3, I promise. Okay? In the 4 column, that's where it gets a little tricky, but in general, those guys, they do something in particular, and so they tend to, if needed, become a -4. If they're going to become an ion, because they're going to gain 4. They tend to gain instead of lose. Okay? In the 5 column, they're right here, so they're just going to gain 3 electrons. 3 extra electrons makes them have a charge of -3. 6 needs 2 to get to 8, so it gets a charge of -2. 7 needs 1 to get to 8, and so it's there. Now, those guys in that last column are extra special. They are the noble gases, and they already have 8. That means they don't form ions. So there are no ions here. No ions. No ions form in that last column over there. Helium, remember, only has 2 electrons. It's the exception. It's happy with 2. Only 2 electrons can fit on that first energy level, so that's all it needs. So then it's done. Okay, so now you understand a little bit about how ions form and the charge of an ion that does form. Remember, it's that octet rule. We're really going for the 8 valence electrons. 8 is going to be a super magical number, as you'll see as the unit progresses. Thanks for watching. Now we have one more type of ion to talk about, but I'm out of room, so I'm going to just write this on the next page, and if you didn't put in a periodic table here, then you probably still have enough room. So polyatomic ions are the things that we have to pay attention to next, and polyatomic ions they're charged particles also. Remember, they're ions, and an ion means charged particle. We had the cations that were positive and the anions that were negative. When we talk about a polyatomic ion, it's not an atom, it's a charged molecule. So those atoms are stuck together in a molecule, and then the whole set becomes charged. Now, there's something special about polyatomic ions is that we have a whole bunch of them, and they have special names. So find your periodic table. Here's my periodic table. Yours might look a little different because I think I reorganized things, but right up here it says polyatomic ions. These are the common ones, and they are in order by their charge. So we've got some positive ones and some negative ones, and they all have names, and they have a formula right here, so it shows you the charge. Some popular ones that we'll see a lot are sulfate, let's see, what else do we see? Carbonate, phosphate, nitrate, chlorate is one that you'll see a bunch. Hydroxide is really popular. You might see those plenty of times. And so when you see a combination, notice how there are 2 or 3 capital letters. That's how you know it's a little molecule. Remember, when it's 1 capital letter, it's just an individual atom, and when it's 2 capital letters, those are bonded together. So we'll learn more about those bonds and what holds them together later on, but these are some of those polyatomic ions. So that concludes our talk about ions. If you have any questions, make sure you ask your teacher. Thanks for watching.